Hello everyone, welcome. So this is the 2.5 Quizizz activity for our geometric sequences. So when we're talking about these geometric sequences, we're looking at these numbers that are in an order, and there's a common ratio that is being multiplied or divided each time to get the next number. So with geometric sequences, we're multiplying or dividing, and that's the big difference between that and an arithmetic sequence, okay? So looking here for the first one, we are going from 10 to 20. So it's getting bigger, so we're multiplying. 10 times 2 gets us 20. Let's see if that works for the next one. 20 times 2 is 40, and 40 times 2 is 80. So our multiplier here is 2. So you're going to plug in a 2, and we'll go to the next one. Beautiful. Okay, so this next one we're looking at is, let me clear the screen, 7, negative 7, 7, negative 7, okay? And it follows that same pattern. So again, we want to think about what are we multiplying by to get the next number. And it's looking for the explicit formula for this sequence, okay? So our explicit formula means a sub m, or any certain term is going to be the first term, a1, times our common ratio to the n minus 1 power, okay? So if we wanted to find a sub n here, we would need our first term, our a1, which in this sequence is a 7. So we would start with 7 times, to find the common ratio, how do we go from 7 to negative 7? What are we multiplying by? Right, the number is staying the same, it's just changing signs. So we multiplied by a negative 1. Negative 7 times negative 1 is positive 7. Positive 7 times negative 1 is negative 7. So our multiplier is actually negative 1. And then we have to the n minus 1. So looking at our options, this one here is what we have created. A to the n equals 7 times negative 1 raised to the n minus 1 power. So when you're all set, you can click that, and we'll look at question number 3. So for this one, we're going from 3 to negative 12. So you can look at any two terms and think about what that multiplier is. If you're not sure what the common ratio is, remember you can take the second term, negative 12, and divide it by the first term, which is 3. Oops. So negative 12 divided by 3 is negative 4. So what happens here is we're doing 3 times negative 4 to get negative 12. Negative 12 times negative 4 to get a positive 48, and so on. So our multiplier is negative 4. So you can always use division to work yourself backwards to figure out what the common ratio is, if you don't see it. Like maybe you know 3 times 4 is 12, and that's great. But if you're not sure or you want to use division to check, you can always do that. Question 4, we're looking for the explicit formula. So again, a sub n equals the first term times the ratio raised to n minus 1. So our first term here, looking at the sequence, is a 3. So already we know it can't be this one and cannot be this one, right? Using process of elimination, because our first term is a 3. Now the ratio, remember from the last one, 3 times negative 4 gets us negative 12. So our common ratio is negative 4 to the n minus 1. So that's going to be option D. Beautiful, friends. Nice work. Question 5 wants you to find the common ratio here. Now, when I'm looking at these numbers, the common ratio is not super simple for me to see. So I'm going to use my division trick to figure it out. And you can pick any two. So let's pick these two. So you want to put the later one on top, divided by 72. This is what I'm going to do in my calculator. So we did 48 divided by 72. And it gives us this messy decimal. You can hit the fraction button, and our multiplier is actually 2/3. So if we go back, this is equal to 2/3. That is our multiplier, and we can check it. Let's do 162 times 2/3. 162 times 2/3. And we get 108, which was the next number in our sequence. 108 times 2/3, 72, right? That's working. That's exactly what our common ratio is. Nice job, y'all. Question 6 says the next term of the sequence is what? So we're going from 2, 4, 8, 16. How are we getting there? They're getting bigger. That's a geometric sequence. We're multiplying. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So we noticed that the common ratio was 2, and then we just kept multiplying by 2 to get our next term. Beautiful. The image shows a certain bacteria grows in a petri dish. What is the common ratio? Okay, so at the beginning, we had 3. 1, 2, 3. Now the bacteria has grown. We have 2, 4, 6. After 2 minutes, we have 4, 8, 12. After 3 minutes, 8, 16, 24. After 4 minutes, 16. Each block is 16, 32, 48. So we look at these options, and what is our multiplier? How do we go from 3 to 6? Well, we doubled. We multiplied by 2. 6 times 2 is 12. That's correct. 12 times 2 is 24. 24 times 2 is 48. So our next, so our common ratio, which is what it was looking for, is that multiplier of 2. So we're going to go back and select 2. Nice job, y'all. Find the first 4 terms of the sequence given this rule. So we have, this is fun, a sub n is 4 times 5 to the n minus 1. So remember, our a1 is in the front, so our first term is a 4. So we know it's not A and not B. Now our next thing tells us, hey, the multiplier in the parentheses is 5. So we're multiplying by 5. And what's 4 times 5? 20. So our next term will be 20. And then what's 20 times 5? 100. And finally, 100 times 5 is 500. So here is our answer for question 8. Nice job, y'all. Write the explicit formula for this geometric sequence. So, a sub n equals a of the first term times the rate times n minus 1. So our first term in this sequence is 3. Our common ratio is going from 3 to negative 12. We saw this one earlier when we multiplied by a negative 4. And then we have our n minus 1. So we have 3 times negative 4 raised to the n minus 1 power. Good. So notice a lot of these look similar, so we want to make sure we're putting our first term in front of the parentheses. That's our first term placement. And what's inside the parentheses is our multiplier, or common ratio. Perfect, y'all. We're going to look at question 10 next. Is this sequence geometric? Okay, so we have 9, 99, 999, 9,999. Very fun. So to go from 9 to 99, we multiply by 11, right? I can check that in my calculator. 99 divided by 9 is 11. Beautiful. So if it is geometric, if we multiply by 11, we should get 999. So let's do 99 times 11. 1,089. That is not 999, so this is not geometric. It has to be the same multiplier each time to be geometric. Question 11, is this one geometric? Okay, so let's look at what we have. Negative 4 to negative 12 to negative 36 to negative 108. Negative 4 to negative 12. Again, if you're not sure what that is, you just do negative 12 divided by negative 4, which is a positive 3. So we had negative 4 times 3 got us negative 12. So next, let's see what negative 12 times 3 gets us. Negative 36, which is correct. Last one, negative 36 times 3 is negative 108. Beautiful. So this is using a multiplier of 3 every time. So yes, this is geometric. Question 12 wants you to find the common ratio here. So you can just pick any two numbers. A lot of the times it's easiest to start at the beginning because the numbers are usually smaller towards the front, but you don't have to. So how do we go from 4 to negative 16? Well, we're multiplying by a negative 4, right? If you weren't sure how to get that, you could do negative 16 divided by 4, and that would show you negative 4 as well. Or you could do 64 divided by negative 16, and that would get you negative 4 too. Or negative 256 divided by 64 would also get you negative 4. There's our common ratio. Beautiful. The pattern followed by the sequence is what? So we went 3, 6, 9, 12. The pattern followed by this sequence, we're looking at multiples of 3. We're just counting by 3s here, right? 3, 6, 9, 12. Then we would go 15, 18, counting up by 3s. The next term in this sequence, so we have 4, we have a 16, and we have a 64. So how do we get from 4 to 16? What are we multiplying by? By 4, absolutely. So then 16 times 4 is 64. So we have to do 64 times 4. Well, 4 times 4 is